All right, Integrated Math 3 students. So we are very much at the end of this unit. We've been talking about rational expressions and equations. And we have something additional here to close things out with simplifying a rational expression. We have an example right here, and I want you to go ahead and write this down in your notes. Let's look at this together, and let's think through how you would want to do this. Okay, the reason we're doing it is because you can look forward to seeing an example similar to it on your test. Okay, so when we initially look at this example here, and as you've been instructed to do, the first thing you want to do is try to factor the top and the bottom separately to try to divide away those common factors. Okay, so we start with our methods here. We have GCF. Is there a GCF top or bottom? There's not. Okay, so we can't use that. Quadratic. Are these quadratics? No. Difference of squares. Well, we have even powers here, so that's good. But then 10 and 8, they're not perfect square numbers, so no, that doesn't work either. And then grouping. Does grouping work? No, there's not 4 terms. So immediately, it almost seems like this is actually an impossible task, and it can't be done. Okay? But I'm going to go ahead and tell you that there is something we can do. First off, if you use synthetic division on this, it would actually work. You could get the exact answer that we need and that we will get through another process, but long division will work in this scenario for those that feel comfortable with it. But let's talk about what we can do. Okay, so there is some arithmetic manipulation that can happen with these, and we're going to have that happen right here. So I want you to follow along and see what I do. Okay, on the top, I'm going to change it to this, and I want you to look at that, think about it, and think why I would do that, and is it actually equivalent? Look at the top, look at the bottom. Are these equivalent statements, right? That are equivalent expressions in the numerator. Yeah, they are. -8 take away 2 is -10. So this is a correct way to write this. It doesn't seem as simplified, but it is going to be the process we need to help us simplify this. Now on the bottom we have x minus 4 over or x to the 4th minus 8. Now we cannot just start crossing through this. Remember, we can't divide away terms that are separated by subtraction, so it doesn't work. But we can do another process, and this happens to deal with properties of fractions. So I can actually now make 2 fractions. And this is going to be extremely important. Okay, I can make 2 fractions. One of them is going to have this -2 on the top. The other is going to have x to the 4th minus 8. Okay, so I've just split this top expression up. Okay, this is sort of the opposite of adding fractions, because what's on the bottom of both of these? Well, it's going to be x to the 4th minus 8 and x to the 4th minus 8. Now let me explain this in a simpler way, just so you can see like what exactly did I just do. If I had 8 over 7, all right, that's the same as me writing this as 7 plus 1 over 7, right? And then I can just break this apart to 7 over 7 and then 1 over 7. Okay, now if I just went straight from here to the improper fraction, this would be 1 and 1/7, right? Just doing that from what you understand about fractions, 1 and 1/7, right? So what happens here? Well, 7 over 7 becomes 1 plus 1/7, which is going to get me the same thing. So this reasoning with fractions, again, everything looks more complicated when you put variables in here, but hopefully that basic example down there sort of helps as an analogy, or sort of works parallel with what we're doing up here. I am splitting apart this top fraction to get a common factor, because it will divide and be 1 there. Okay, so that works. And now I've done this, I've split it. So what is going to happen here? Well, exactly what happened down below with the numbers. This becomes a 1 in the front because these are the same, and I can actually cross through the entire term now because it's the same. And just this whole expression over here is to its own thing. This is an individual expression, okay? And now this is an individual expression here. So I'm allowed to do that. I know there's a lot of complicated rules involved with these, but I'm able to do that. Now, what happens here? -2 over x to the 4th minus 8. Well, nothing. There's no factoring that can occur on the bottom here. Nothing can happen up top. So this is plus -2 over x to the 4th minus 8. If you had done long division to work this, you would get the exact same answer, okay? So either way works. I think this way is faster if you really do understand it very well. The reason I'm talking about it is because you need an example, like you're gonna have an example like this on your quiz or your test, okay? So we're going to stop this here. It only took me 5 minutes to sort of talk through that. I don't have any practice problems. Your Delta Maths already do, but I would definitely say if you need to, watch this video again just to really understand what happened. You can rewind it. It'll be on my YouTube under IM3 2021. You should be able to find it with most recent uploads if you just want to watch it again, okay? So I'm going to go ahead and stop it here.